Okay, it's time for another quick video lesson. The topic is the y-intercept and the gradient of a straight line. Now, we've already introduced the idea of y-intercept and gradient, so in some ways this section is a recap. I'm following the textbook, but I've also included a couple of extra things. First of all, a reminder that the y-intercept of a line is the y value of the point where the line cuts the y-axis, cuts or crosses. If a point is on the y-axis, then its x-coordinate is 0. This means that you can always find the y-intercept by substituting x equals 0 into the equation. So the first example, find the y-intercept of the line with equation y equals 2x plus 1. So we let x equals 0. And we substitute that into the equation. Remember, it's a good idea to put the value of x in brackets so that you can see very clearly what substitution you have made. And we evaluate 2 times 0 plus 1, which of course equals 1, which means that the y-intercept is the point 0, 1. Now the second example I'm going to do a little bit differently. Remember that we've introduced the idea of a standard form of the straight line equation, y equals mx plus a constant, which is sometimes labelled c in textbooks, but here I'm using b. So y equals mx plus b, m is the coefficient of x, and that gives the slope or the gradient of the line, and the value of b is the point at which the line cuts the y-axis. In other words, it's the y-intercept, and the point is 0, b. So we're going to use that fact, noting that this equation is in standard form, so we can simply read off the values from the equation, and -5 must therefore be the y-intercept, or we can write it as 0, -5. So what is gradient? Here's a way of illustrating it. We can think of a car going up a hill. Question is, how can we measure the steepness of a hill? And one simple way to do this is to measure how far up in meters the car moves in the vertical direction, which we call the rise, for every 1 meter that it moves in the horizontal direction, which we call the run. So we can then say that the gradient of the hill equals rise over run. This is a simple ratio. Gradient equals rise over run. And using this idea, it wouldn't be too hard to see that the hill on the left is steeper. We can use a similar idea to measure the slope of a straight line graph. Now here's a summary. We've already seen that a positive gradient means the graph is going up in the left-right direction. A negative gradient, you'll recall, means that the graph is going down in the left to right direction. I've included a graph where I've labelled rise and run, and the formula or the rule that we use for finding gradient or slope is just rise over run. And note that this is true for both positive and negative slopes. There's also something else to note too. In practice, when you're finding the slope from a graph, you can use any triangle that touches the line, as long as this angle in the corner of the triangle is a right angle. So here we could also label the red lines as rise and run as shown, noting that the ratio of rise over run for the red lines is identical to the ratio rise over run labelled green. So here's a summary. Y equals mx plus b is the standard form for the equation of a straight line. The coefficient of x, m, is the slope or gradient, and b is the y-intercept value. The big idea is that we can read the values for slope and y-intercept directly from the equation. One final example. For this graph we have labelled the point -4, 4 and the point 8, -2. Let's consider a couple of features of this graph. Firstly, note that the rise is negative. Negative slopes or gradients have a negative rise. The second feature to consider is that run is always positive. In other words, we're working from left to right along the x-axis. Now we can actually figure out the gradient from the graph. Remember that the rule for slope or gradient is rise over run, so m equals rise over run, and from the graph that will be negative 6 over 12. The question is, how did we calculate negative 6? Well, it's the difference between negative 2 and 4. Negative 2 minus 4 is negative 6. And similarly for the run, we are taking the difference between 8 and negative 4. 8 minus negative 4 is 12. In other words, we figured out the length of those two lines from the graph. Now we need to simplify that fraction to negative a half. We can also read off the y-intercept from the graph, and the point we note is 0, 2. We now in fact have enough information to write down the equation of this line using the standard form y equals mx plus b. In place of m is negative a half, so y equals negative a half x, and in place of b we write 2, so the equation is y equals negative x over 2 plus 2. Your turn. Have a go at these exercises. See how you go.